This is Chapter 1, The Language of Algebra. Chapter 1, Section 1, Real Numbers and Their Graphs. You should be writing this down in Cornell-style notes. Write the Chapter 1 and the section title, Section 1, Real Numbers and Their Graphs. State standards are ESLER-D. It's an Algebra 1 standard, so we don't have to put that down for Algebra 2. Our real numbers are what we're going to be studying most of the time in Algebra 2. So what I'm going to do is tell you the subsets of real numbers. In algebra, sets of numbers are put together sort of like layers of a cake, or maybe the layers in a pyramid. At the bottom base would be natural numbers. Now, natural numbers are numbers that you should be familiar with, but you may have forgot about them. The natural numbers are the numbers 1, 2, 3, 4, and they continue on. The three little dots are ellipses, means continue in the same pattern. So we have 1, 2, 3, 4, and naturally the next one would be 5, 6, 7, 8, etc. Next, we add what we call the whole numbers. Now the whole numbers are the natural numbers plus the number 0. So the whole numbers consist of the set 0, 1, 2, 3, 4. Nice and easy. After the whole numbers, we continue building up our real number system with the integers. This is nothing new, so it should be fairly easy to understand that the integers include the whole numbers and their opposites. So we have negative 1, negative 2, negative 3, negative 4, onward with the three ellipses, and then the whole numbers 0, 1, 2, 3, 4. Onto this, natural numbers, whole numbers, and integers, we add the rational numbers. The rational numbers consist of all fractions and decimals. Later on in the course, we're going to learn that decimals are nothing but fractions, and fractions are nothing but decimals. So we kind of lump them together. They're called rational numbers. And again, we could see real numbers are gradually increasing in size. After rational numbers, we have irrational numbers. Irrational numbers are so named by the Greeks because they couldn't figure out their exact values. And we'll cover that later in a different chapter. Rational numbers include square roots of primes and relatively prime numbers. So we have something like square root of 3. We would also have something like square root of 6. Square root of 6, of course, 6 is not prime, but 6 is relatively prime in the sense that we can't simplify it any further. We also have all negatives, so something like negative square root of 2, and of course the most famous irrational number of all, pi. So what we have is a group of 5 different sets: natural numbers, whole numbers, integers, rational numbers, and irrational numbers that make up the real number system. Now there's a general rule that we usually apply in Algebra 2, and that is each point on a number line can be paired with a real number. So if I have a number line with a point on it, now let's say we just draw it on a number line and it looks like this, and I pick some point and we call it A. Alright, so we have A and some point. That point on the number line corresponds to one of those real numbers that we had set up. So we see that it's negative 2 in this instance. So the point A corresponds to negative 2. Negative 2, of course, is an integer. So is that the only ones? Well, not exactly. We could find something like this, point B, and we could see it's halfway between 1 and 2, and that comes up as 1.5. So we could also have decimals on our number line. So we could have all real numbers. So even irrational numbers will have a point, or a point has a irrational number as a coordinate. Now, let's suppose we take that general rule and find a converse of it. The converse would be each real number can be paired with a point on the number line. So in the first statement, each point on the number line can be paired with a real number. Its converse, each real number can be paired with a point on the number line. And we call that a graph. So that's nice and easily understood. Let's look at another example. Let's say I pick the integer -3. I can find a point on the number line that corresponds to it. So in this particular example, I have it labeled as x. Notice we're doing the converse. We're going opposite. Let's suppose I pick another coordinate. Let's say it's 2.5. I could find a point on the number line that corresponds to 2.5. I'm going to label this y, so that we have some sort of idea about coordinates going with points and points going with coordinates. When we find points with coordinates, it's called a graph. And we'll be doing a lot of those in other chapters. Our next idea, nice and easy, this one I really like, it's the concept of opposites. Not unusual, you should understand this fairly easy. Let's take a coordinate like -2. Its opposite, of course, would be +2. And we usually write an opposite with a negative sign. So we think negative -2, the opposite of -2, +2. Here we go the other direction, +4, -4. So the opposite of 4, -4. Now we come to a little concept that's very important, and I'm going to present it a little bit differently than it does in the textbook, although this is in your textbook also, and that's the idea of absolute value. Now you should be familiar with absolute value. You probably learned about it in Algebra 1 as the distance away from the point 0, and your number always came out positive. We're going to look at a more mathematical definition of absolute value and learn it this particular way at this particular time. And it will really be helpful if we learn it this way, especially in the next chapter. So, absolute value is defined as the absolute value of x equals x if x is greater than or equal to 0, or absolute value of x equals the opposite of x if x is less than 0. So it's pretty easy. The idea is if it's positive, it's the same value. If it's negative, we take the opposite of it. So let's look at our little example. We have 2 examples here. Oh, actually we have 4 examples. We have the absolute value of 7, absolute value of -8, absolute value of x plus 3 if x plus 3 is greater than or equal to 0, the absolute value of x plus 3 if x plus 3 is less than 0. So our first example, absolute value of 7, the solution is fairly easy. 7 is greater than 0. So the absolute value of 7 is just that value, 7. For the next one, absolute value of -8, we take the opposite of -8, +8, and that's our value for the absolute value of -8. Pretty easy, huh? That's exactly what you learned to do in Algebra 1. Now, our problem, of course, is that we're in Algebra 2. So if we take a look at the example, the bottom left one, we have the absolute value of x is equal to what if x plus 3 is greater than or equal to 0? Well, according to our definition, since x plus 3 is greater than 0, the absolute value of x plus 3 is just x plus 3. The bottom right-hand one, absolute value of x plus 3, but x plus 3 now is less than 0. Right there, the second part of it after the comma, x plus 3 is less than 0. It's the opposite of x plus 3. And we write opposites, of course, with a negative sign. So we have absolute value of x equals negative x plus 3. Notice I put the entire segment, the entire statement, x plus 3, in parentheses. And it's going to be pretty important that you do that. And in class tomorrow, I'll show you why it's important. Our next little concept, nice and easy again, the distance between points. Now this is a definition. Definitions, of course, are by understanding is a statement and its converse is also true. So this will be pretty easy. Distance between points. The distance between points is the absolute value of the difference of the coordinates. So the distance, and I just wrote it out using an English word, distance equals absolute value of x minus y. So let's take a look at a simple example. In this example, we're finding the distance between two coordinates, negative 6 and positive 3. So, what do? We find the difference between negative 6 and positive 3, and then take the absolute value of it. So I have absolute value, negative 6, difference means subtract, so it's subtract positive 3. And of course, we add those two together. It's negative 6 and negative 3. So that's negative 9. Absolute value of negative 9. Negative 9's, of course, less than 0. So I take the opposite of negative 9. And it comes out 9. So what do we do next? Well, let's suppose we did it the other way around. Suppose we went 3 minus negative 6. Do I get a different answer? I have 3 minus negative 6. And of course, negative 6 is positive 6. Add them together, 9. So the absolute value of positive 9, of course, is just 9. So I get 9. And it's the same answer for both. And you would kind of expect that you would have the same answer for both. After all, it is the distance between the point negative 6 and 3. They have to be the same. Now, we finish with today's notes for your notebook. You should have everything written up in Cornell style. Make sure you have all the examples written down. And what you want to do, of course, is write in your questions or cues on the left-hand side. And down at the bottom, you should be writing a summary of everything in this particular section. Now, your summary doesn't have to be excruciatingly long. Maybe just a sentence or two. A lot of students like to write down what they learned new. Of course, there isn't much new here. You should understand it fairly well, or at least have prior experience in it. But just write down a short summary. Use only about a sentence, maybe 2 sentences at the most. Tomorrow when you come into class, I will look over your notes, stamp them, and then give you your problem assignment, and we'll work on those in class. If you have any questions, please wait until tomorrow, and we'll talk about them. Okay? Have a nice day.